You're the it's good. And we're going to talk about examples of these too. The way I remember it is empirical, starts with an E, and it's when you actually do an experiment. So, empirical experiment. Theoretical is what should happen when you do the experiment instead of what actually does happen. For example, the probability that if you flip a coin 100 times, how many times should you get tails? 50. Yeah, half the time. It's a 50-50 thing. That's theoretical probability. Empirical probability is actually flipping the coin 100 times and seeing what actually happens. So, for example here, actually rolling a die. Would that be empirical or theoretical? Yeah, that's empirical. You're actually doing it. 50% chance of rain. That's theoretical. Yeah, because for empirical, it would be either raining or not. Half the people in the world are males. That is theoretical. That's what it should be. May or may not be what it is. Flipping a coin. That is empirical. That's right. So empirical is when you actually do something. Rolling a die, flipping a coin. Theoretical is what should happen. Whether it actually happens that way or not, meh. How to find empirical probability. P parentheses E, that just means the probability of an event. Is the number of times the event, E, has occurred over the total number of times the experiment was completed. So, for example, if I tell you that I flipped a coin 10 times and I got tails 3 of the times that I flipped that coin, then the probability of tails, that's because the tails is in parentheses, is first the number of times that the tails has occurred, which is 3, over the total of number of times the experiment was done. I flipped the coin 10 times, so it's 3 out of 10. Now, if it would have asked you for heads, then obviously if I flipped it and got tails 3 times, then how many times would I have gotten heads?
7 out of 10.
7, yeah, 7 out of 10 times, good. If that would have been something that you could reduce, say it was 4 out of 10, then you should reduce it to 2 out of 5. But do leave it as a fraction. Okay, jot this one down. We'll figure it out, basically. If you needed a calculator to reduce it, that would be fine. Just not to give me a decimal answer. I wouldn't take it. Okay, 100 times we flipped a coin, 44 landed heads up. Find the empirical probability of the coin landing heads up. So without reducing first, what number would go on top? 44. Because out of those 100 tosses, we got 44 that were heads up. And then on bottom, what number? 100. Good. Now we can reduce it. What do you want to divide them by? You gotta find a number that will go into the top and the bottom evenly. Four, thank you. Okay, 44 divided by 4 is 11. And 100 divided by 4 is 25. Will not reduce anymore, so that's your answer. If you had divided it by 2, you would have gotten 22 out of 50, and then you could have divided it by 2 again. So it is okay, whatever you decide to divide it by, but you have to have it in fraction form. You don't want a decimal. Sorry. Law of large numbers. It's pretty self-explanatory. Basically, the more times you do an experiment, the more accurate it's going to be. For example, if we flipped a coin 10 times, we probably really would not get 50-50. It may not even get close. But if we flip the coin 1,000 times, we'd get a lot closer to having 50-50. If we did it 1,000,000 times, it'd be even closer. And nobody wants to do that, but that's what the law of large numbers is. Okay. This assignment, I'm going to, of course, post, but if you'd rather have something paper, because we're going to work on it in class either tomorrow or I may have to get Wednesday out now. But it's these yellow books back here. That's actually what page it's talking about, but I will post the work online. You don't have to start it right now. You can do it